This is the Unitree 4D Lidar L2. It is a successor to the L1. This one has twice as many points per scan. It's supposed to be able to give you point clouds that look like this. In this case, the LiDAR was probably looking straight up, and while the robot was taken through a walk through the park. It scans a hemisphere of points at about 5.55 hertz, but it has an additional mode to negative angle mode to gain an additional 6 degrees of down angle. But when you put it in that mode, it sacrifices a little bit of range. It's not specified exactly how much it sacrifices. The top half of the sensor will spin in operation, but there are actually two different brushless motors inside. One is revolving the whole sensor assembly around the primary vertical axis at over 5 times per second, and the other is spinning the mirror in the secondary horizontal axis at about 216 times per second to create a vertical slice of points. And subsequent slices get assembled as the primary axis continues to rotate. So this cutaway shows the path that the laser light is taking. The vertical slice happens over about 1/39th of a primary rotation, or about 9¼ degrees. So there are big gaps, and it's a pretty sparse point cloud. But this vertical slice is designed to precess as the thing is turning, to cover the angular gaps over time, and we'll see how that works in a little bit. The laser is rapidly pulsed, so it's not on all the time. This helps limit the total power consumption. I'm sure it's off while the mirror is pointing it down towards the main board. So Unitree claims that we can mount this sensor in just about any direction. Normally it might be facing up, but Unitree shows examples of it looking down. Here it's on their Go-To robot, and here it's pointing down. It's also covered by this cage to protect it from collisions. Here is one of their bigger robots on wheels, and it's looking forward. And in this orientation, it might be a little bit better for navigation and mapping. I've seen other examples where they're just sitting on arbitrary angles. The optical window is the section that you need to keep clean. And this gap between the rotating upper part and the base right here, this is showing the area where you'd want to shield it against water ingress if you're operating it outdoors, because rain can get into that little gap right there. Otherwise, it's got sort of decent, operating range. It's an IP54 rating. It can go from -10 to 50 degrees Celsius in range. I think it'll keep operating until the internal temperature goes up as high as 80 degrees. And it's supposed to be able to work under 100,000 lux, which is sort of like the brightest sunshine you'll see in Texas. And it can do 15 to 30 meters of range, depending on how bright the target is. These are the specifications. I'm not going to go into great detail. I've already covered a fair number of them, but again, you can see it's 64,000 points per second. The accuracy is at 2 centimeters roughly, and the resolution is like every 4.5 millimeters. So when it's really up close, I'm not sure I'm trusting the values all that much. It's got a 6-axis IMU, and the rest of these are available on my companion document linked below in the description. So I also have an unboxing video uploaded to YouTube, and the link to that is in the description if you want to see what it looks like right as it comes from the factory. So here's the unit. Oops. It's this seam right here that needs to be water protected. The cable is 3-pronged. So this is the Ethernet connection. It does not support PoE. Instead, you plug power into this. I think it's a 3.5 millimeter barrel jack, positive on the inside. And then this is the serial or UART cable. And right now I've got it plugged into this board, which also came with the unit, which acts as a serial to USB bridge. You'll notice that there's another barrel jack right there. Do not use that one. That is meant for the little brother to this is the L1 unit, and it has just the single connection, and it also takes power from this board. But for the L2, you want to use this dedicated barrel jack. So I'm going to go ahead and plug them in. And by default, it's going to want to power up the minute I plug in the barrel jack. There it goes. And you're seeing it like wobble around a little bit. There is a, where did I put that? They send a rubberized mat to stabilize it, give it some grip so it doesn't flutter around so much. And then I'm going to connect the USB-C connector. And then I'll be able to connect to the unit. So the software you'll want is called Unitree Lidar L2. You'll go to their download center for the L2, which is this address. You can also get it from my companion document that has the download links in it. And you'll go down to right here. This is the software. You'll download it. This only works for Windows. And it's only meant to configure the device and explore settings. It doesn't let you do anything with the point cloud data other than to view it. To actually use it, use the data, you need to use a API or a RAWs integration. And it's just a raw download, so once you download it, you'll just run it. There's no installer. You'll probably get a security warning, and you'll have to just accept that. So once you load up the software, it looks like this. I'll explain. So this section right here is where the point cloud will show up, and then there's some configuration panes over here. So the top section lets you configure the connection to the device. The next section is this tabbed interface right here, where most of the settings are defined or viewed. And then the bottom section is solely IMU data. So the first thing we need to do is connect. Now I've got it connected to the UART. So I'm going to go to serial mode. In my case, it's COM3. And then I'm going to open the serial port. Nothing changes on the display. There's no telling. I think you get an error if it doesn't actually connect properly. But anyhow, the next thing we're going to do is go down to this section right here. It starts out on this LiDAR info, so this is a real-time feed, but you'll see that there's nothing running right now. This is the work mode, and you got to be kind of careful here because this contains a lot of settings, and when you first start the software, it's going to come up with the default settings. It's not when you connect to this to the serial port or over UDP, it doesn't refresh these from the device. So if you don't refresh from the device, get your settings off of the device into here, you have a risk of pushing the default settings back over and wiping out the whatever your current custom configuration is. So the most important thing to do is right after connecting, go down here to these buttons. This one that says synchronous right here is kind of mislabeled. maybe it would make sense if it was just called sync or get settings, but basically that gets the current device configuration and pushes it up into these settings right here. So I'm going to click on that and you'll see these change. Got this. All right, so now you'll see that right now we got the IMU disabled. We've got it in normal mode versus negative angle mode. And it's set to self-start. What that means is anytime you plug in power, it'll automatically just start spinning as opposed to be command started. So you need to, if it's command start, then you'll have to send it a command to start it. And this is basically the button that puts it into start versus standby mode. Anytime you change one of these things, sometimes it'll take effect immediately and you'll see it over here. Other times you have to actually click set mode and then you have to restart the unit. You'll just have to play around with the settings until you figure it out. The point cloud is the only one that is not actually a setting that you store in the device. All this does is set the decay time for how long the points streaming in from the device stay in this display. And you'll get a feel for what that means in just a minute. So I'm going to go ahead and pop up the camera. And let's see this guy start up. So this button is not so great either. It's the opposite. So right now you can see that it's standing still. It's not actually on. So if I click normal, it'll put it into standby mode and then tell me standby. And it still hasn't done anything. Now I have to click it again and it'll go into normal mode. And this will start it spinning up. Now you can see that the sensor is spinning up, and it can take a good 15 seconds for it to fully come up. I'm going to zoom in here a little bit. In a few more seconds, we should start seeing the data come in. There we go. All right. So what we're seeing is a bunch of vertical scans. This is the Y, the vertical direction right here. We're seeing a bunch of vertical scans. So the unit is sitting at the nexus of this origin. And this point cloud right here is actually the camera that's looking down on it. So it's looking up and it's seeing the camera. What you're seeing is that it's keeping the points that are streaming in for 500 milliseconds, so half a second. Since this thing is going around and around at 5.55 hertz, then we're not really at a full. It's keeping less than 3 rotations of these vertical slices on the screen at any one time. And what that sort of lets you see is this precession that's going on, right? Because there are pretty big gaps between subsequent scans. You know, it's up to like 9 degrees of separation, something like that. But because because it's not a proper fraction of 360, the scans advance as they go around. So over time, it'll build up, and you'll get more coverage of whatever surfaces. So here, I'm focused in very closely. The sensor is just sitting on a table right here. I think that this is me right here. Yeah, see this right here? This is my hand that I'm putting out to the side of the sensor. So what I'm going to now do is zoom out, and you'll see the full room. And you'll get a real sense of the precession of the subsequent readings. So this room is about 20 feet across this way and about 20 feet deep this way. And the ceiling is maybe almost 30 feet tall. And this point cloud is looking, it's looking pretty sparse. So if I do gray, and so gray right now they call it 4D because the fourth dimension is technically the luminance of the returned points. So it's giving you a gray value for that. If you turn that off, you'll get less data per point, and it's going to sort of colorize it for its distance from the sensor. I'm not sure why it goes through this gradient all the way to red and then suddenly goes to white again. So there seems to be some cutoff for that gradient, but that might be a weirdness in this software specifically. If we change the decay time, you'll really see the points fill in. So I'm going to change it to 4 seconds. And now we can see the points really fill in. And we'll get a better sense for the flatness of these surfaces. So again, this may be a good thing to do as long as, particularly if you're on a moving robot, you'd want your robot to have really good localization, odometry and localization to make sure that subsequent scans while you're moving are properly correlated with their actual location on the surfaces. Otherwise, you'll get sort of a fuzzy, messy point cloud. But yeah, this is the basics of this sensor. Now I'm going to go ahead and enable the IMU. And for this, I think we're going to have to do a restart. So I'm going to do a set mode to enable it. And then I'm going to do a restart. Oh, I had the camera up that whole time. I probably should have hit it. All right, we're gonna, again, it's gonna take a minute for it to spin up to full speed and start displaying data again. But you can see that the IMU is enabled because now we're getting this data down here. So I'm going to hide that camera again. So one weird effect is that when you turn on the IMU, you start getting your IMU data, but you can no longer rotate this display freely because it's trying to lock its orientation to the IMU itself. So if I'm going to tip the camera, and you're going to see the display follow the IMU now. What you're also seeing is that all of this got really muddy and sort of delocalized. And that's a result of the fact that this unit at least is kind of unbalanced. So I'm going to hold it loosely in my hand, and you can see it rocking my fingers. And the IMU is sort of lagging here, trying to update the display to the speed of the wobble. So this wobble is definitely going to, if you don't have the robot or the sensor mounted well to a heavier robot, then this is going to give you a sort of a messier display, and your point data. But basically, there's going to be a lot of error buildup in your point cloud. In fact, I can't even, like, the harder I grip it, I can sort of damp that better. But you can still see that there's, the tiniest bit of vibration is going to add some fuzziness to the to those walls, so that they're not perfectly in the same plane anymore. When I put it back down on the ground, that should all clean up. See all that data clean up. If I then go to disable here, but without setting the modes, now I can rotate it again. So again, that's just a weirdness of this application. The things that you're seeing here is because it's at night, we're getting we're getting these extra projections coming out of this space. And these are actually reflections of, so for example, there is a window right here. It's kind of hard to tell. But so when the sensor points up at the window, it's getting a reflection off of this wall right here. and it sort of projects it outwards. So that's the problem with windows and mirrors generally with any kind of visual sensor. You got to sort of figure out how to deal with some of the false artifacts. But again, it's pretty stable once you put it, on a hard surface, and the mounting bolts underneath it should let you mount it pretty well. So, but I think that a robot, under say 15 pounds might not be able to provide the steadiness that this particular unit needs. I don't know if that's normal. I don't know if the amount of wobble is within spec or not. That's not defined anywhere. So this is the sensor in 2D mode, and you'll notice that this primary axis isn't spinning. Sometimes it does spin in 2D mode. I haven't figured that out yet, but if you start up in 2D mode, it shouldn't be. But what's happening is the laser is scanning over the dome here, and that bright spot is the laser going straight up into the lens of the camera. And what you're seeing right here, this line right here, is the face of the camera up overhead. And this is the edge of my laptop. And if I zoom out, you'll see the outline of the room I'm in. So that's all I have to share right now. I might do a follow-up video once I've got it fully integrated with my ROS 2 robot.